Assalamu alaikum everyone. Welcome to lab number 6. Lab number 6 is about recursion, and therefore the objective is to learn how to implement recursive methods. Now in this lab we have seen actually all the examples that I have listed here in the lecture. In fact, we have run each and every one of them. We saw 6 different examples about recursive methods. The factorial, the Fibonacci, the print to, the print odds, the power, and also the add array. So all these examples, if you download the lab and you open the project, lab 6 project, you will see all this example in the project. So you can test run them again yourself after going through the code to make sure you understand it. Then run the programs and make sure they are working correctly. I have nothing more to add other than what I have already explained in the lecture. So all I'm going to do is I'm going to go through the tasks that you are supposed to do. Okay. Task number 1. It says write a program that reads an integer n from the user and then print all the even numbers between 0 to that integer number n. Your program must include a recursive method, public static void print evens int n, that does the actual printing. Your program should also have public static void reverse print evens that will print the same even numbers but in reverse order. Of course, this one should also be a recursive method. Okay, update the main method to test your 2 methods here, or write a main method to test your 2 methods. Okay, so obviously this example is very similar to the print odds that we already saw as an example. As a matter of fact, you can just copy and refactor test print odds, save it as test print evens, and then make a minor modification to make it to print the evens. Essentially, all you have to change is, apart from the name of the methods, you also have to change the condition for checking for even. Okay, so there isn't much actually to do here. Is very similar to the print odds method. Okay, so this is task number 1, is to get you started. It's very easy. Second task, write another recursive method, public static int multiply int m int n, that computes and returns the result of multiplying m and n, or multiplying m by n. But here is the catch: without using the multiplication operator. So I want to multiply m by n recursively, but without using the multiplication operator star. Okay, test your method by calling it from the main method. So in the main method, you have to read the values of m and n from the user, and then call multiply to multiply them, get the result, and print it out. Now here is a hint which will help you do this example. It says just like x to power n means x times x times x times x times x n times, so also m times n means m plus m plus m plus m plus m n times. In other words, multiplication can be done actually by just repeated addition. Okay, so you don't have to use multiplication operator to achieve multiplication. You can just repeatedly do addition. This is one point we can observe from this hint. The second point we can observe is that this operation actually is very similar to the operation of power. Because if you recall, power, we said to find the power of x to n is the same as power of x until n minus 1, and then multiply that result by x. Okay, this is the way to define the problem recursively. So in the same way, if you observe this m plus m plus m n times is the same as m plus m plus m plus m n minus 1 times. After that, just add one more m to the result and you get your original answer. So this is the idea. So basically, again, this is very similar to the power method. You can in fact copy and paste the power method, refactor it accordingly. Maybe you can call it test multiply, and then update it to compute the result of m times n. Okay, notice here, of course, that both m and n are integers. And please do not use x, because x is normally used for double values. We just stick to the m and m as integers, okay, in your method. Okay, so this is task number 2. You can see that task number 1 and 2 are really very, very easy. Task number 3. Write a recursive method, public static int find min, that takes int array A and int last, okay, that finds the minimum element in an array of integers from 0 to last, okay, where last is the index of the last element. You should also write an auxiliary method, public static int find min int array A, that will make it easy for a user to call your recursive method without the need to provide the initial value of last. Let this auxiliary method provide the initial value by simply getting it from the array itself, as we did in the add array method. Okay, test your method by writing a main method that will initialize an array of integer with some values. So you don't have to read the values of the array from the user, just initialize the array and then call the auxiliary method. So the user should not call this method, he should call the auxiliary method. The auxiliary method is the one that will call this, so that it will give the initial value of last. Okay, so it will call the auxiliary method to find the minimum element and print it. Again, the hint here is saying this is very similar to add array method. Okay, we are looking for the minimum element in the array. So you have to assume, again, trying to find the reduced version of the problem, you have to assume that suppose somebody has found for you the minimum element from 0 until last minus 1. Okay, if we know that, how then can we find the minimum element from 0 until last? Okay, I leave you to think about that. This is task number 3. The last and final task is this one, task number 4. It says one advantage of doubly linked list is that it can be traversed both forward and backwards, while singly linked list can only be traversed forward because it doesn't have the pre-reference. See, however, with recursion, you can also traverse the singly linked list in reverse. In other words, you can print the elements backward as well using recursion, even for singly linked list. Okay, so and based on that, you are being asked to write these methods. So write a recursive method, private void reverse print, which will take a reference to a node. Okay, you're going to write this method inside the singly linked list class. This is why, if you notice in the project, you are given singly linked list. You need it only for the last task. Okay, so you're going to write this method in the singly linked list, and the idea of it is that it should print all the elements in the list but in reverse order. Print the element in the list in reverse order. Okay. B, write an auxiliary method, public void reverse print. Notice this one doesn't take any argument. To simplify the calling of the recursive method in A above by calling it with an appropriate initial value of temp. Okay. And C, update the given test integer SLL to test your method in B. So again, if you notice, you are given actually test integer SLL in the lab 6 project. So the purpose of this is to help you to test the method you're going to write in the singly linked list class. Okay, so let me try to give you a hint about this method that you need to do. Okay, it says here, think of the original problem as shown below. So in other words, we are given a singly linked list, and we are also given a temp which initially referenced to the first node. And the idea is print the elements starting from temp until the end of the list, but do that in reverse order. Do that in reverse order. Okay, so this is the original problem. Remember the steps I discussed in the lecture about how to develop the recursive definition for the problem. And the first step is to actually think about what is the reduced version of the problem. Because if you can think about that, then you can try to relate the original problem with the reduced version. That will help you to come up with the recursive definition. And then later on you think about the base case. And based on this, you can define the problem recursively. Once you can come up with the recursive definition, obviously you can now convert it to Java code. So I'm saying, suppose this is the original problem. What do you think will be the reduced version of the problem? The original problem says, print the elements from the node being referenced by temp until the last one, but in reverse order. Okay. Obviously, the reduced version of the problem will be print the elements, because we have to reduce the problem size. Remember, that is the idea. The reduced version of the problem should reduce the problem size. So one way to reduce the problem size is move temp by 1, so that temp becomes temp.next. Okay, so this is in the reduced version of the problem. Print the elements starting from this new value of temp. So temp is pointing to the second node here. until the end, but print them in reverse order. Okay, so the idea is, suppose somebody has done this for you. He has printed the elements from this second node to the end of the list in reverse order. In other words, you already have 3, 8, and 5 printed. How can you solve the original problem? Okay, so that 6 will be printed last. So we already have 3, 8, and 5 printed. All that is left for you now is to print the 6. Okay, so this is the idea. Which of this will you do first? Will you print the 6 first, then this, or will you do this first, then print the 6 to have the elements printed in reverse order? Okay, so I leave you to think about this problem with this hint, but this is basically the reduced version of the problem. Okay, if we are given temp starting from head, then the reduced version problem will do the same thing, but starting from temp.next, because if temp is here, it is like temp.next. Okay, think about it and try to do it. It should print the elements in the list in reverse order. Basically, what you should remember is that swapping the two statements alone, because actually here we have two things to do. Print the rest of the elements in reverse, then print the one referenced by temp. Now, swapping the two statements alone will make the element to be printed in reverse. So what you will say is, instead of printing the element pointed by temp, instead of printing temp.info, you delay that until after the recursive call. So when you do the recursive call with temp.next, after that, then print temp.info. You will see that automatically the elements will be printed in reverse order. Okay, I think I have almost solved the problem for you. I leave you to try and do that. So these are the tasks for this lab. Try and do it and submit by the end of the day as usual. Thank you very much.